Hi, this is Jason with Liquid Instruments. This is the second video in a two-part series about how to write, compile, and deploy custom FPGA functions using Moku Device and Moku Cloud Compile. Last time we generated a sample and hold bitstream using Moku Cloud Compile, and today we'll examine how it works in practice. In multi-instrument mode, put Cloud Compile in slot 1 and upload the bitstream. This is where we left off in part 1. Add an oscilloscope in slot 2. Attach outputs A and B of the oscilloscope into inputs A and B of Cloud Compile respectively. Make sure the Cloud Compile signal also returns to the input of the oscilloscope. Output A will be our signal that we will examine, and output B will be our trigger, which will control our sample and hold. Click Apply Changes. Open the oscilloscope, and then the embedded waveform generator, and create a slow oscillating sine wave, say 1 Hertz, just so we can see the effect in real time on the oscilloscope. Let's enable this waveform. Now we can see that even though the waveform generator is outputting a signal, nothing is making it through the Moku Cloud Compile. It's just a steady DC voltage. So let's change the waveform type on channel 2 to DC and set the trigger level to 500 millivolts. Now this is going to act as our trigger signal. So when we enable this, we should see the data start to appear. And if you haven't, click over to the time-based table and set the acquisition mode to roll mode. Now let's enable output B. And we see the slow oscillating signal that we specified over on channel A. If we click output B again to disable the trigger signal, we see the data hold at a steady value. And we can re-enable the trigger, and it will start to oscillate again. We can repeat this any arbitrary number of times, enabling and disabling the trigger signal, and watching the sample and hold function. So in this simple example, we're using the Moku Cloud Compile to implement a sample and hold function, but the device is capable of much more complex things. This bitstream will be available from our GitHub, along with many other useful tools, such as a boxcar averager. The link to our GitHub will be in the description. Check out the rest of our YouTube channel for more examples involving Moku Cloud Compile. Thanks for watching, and see you next time.